Welcome to this video on open source and AI-based integrated circuit design. This is the second part of our series, IC Design for Everyone, presented by Paul Chen. In this video, we will explore the landscape of logical and physical design, the tools available, recommended training courses, and the various challenges encountered in the process. For logical design, we use LLMs to generate specifications, Verilog code, and test benches. Tools like EDA Playground or iVerilog facilitate RTL simulation, while Yosis handles netlist synthesis. We also highly recommend integrating formal verification tools. Moving to physical design, we leverage Google-supported OpenLink. The flow involves synthesis using standard cell libraries like SKY130A, layout with Magic, placement and routing with OpenRoad, as well as static timing analysis and final GDS and spice generation. ChatGPT is a powerful tool in this workflow, helping designers quickly draft detailed specifications, such as this example for a typical D-type flip-flop. EDAPlayground.com is an essential resource, providing a browser-based environment where you can write and run your test benches and designs. For local development, Icarus Verilog is a widely used free compiler for the IEEE 1364 Verilog hardware description language, available for multiple platforms. Yosis acts as our open synthesis suite. It can be easily installed on Windows 11 by utilizing the Windows subsystem for Linux. Simply running the commands shown here. OpenLane 2.0, running via Docker, manages the complex physical design process through an automated flow consisting of 78 distinct steps. This slide displays the final output directories generated by OpenLane for a serial by parallel multiplier project, including design, GDS, and timing files. Here is the visual representation of the layout as generated by Magic, displaying the cells and routing structures of our design. After the initial layout, K-Layout allows us to view and inspect the final GDS results, ensuring all design rules are met. Finally, OpenRoad provides a detailed view of the placed and routed design, helping us verify the physical implementation of our logic. For those just starting out, we recommend building a strong foundation in basic electronics and logic design, followed by hands-on participation in project-oriented lab courses. To summarize the challenges, while LLMs and open-source tools provide great resources for learning and automation, users must be mindful of the tool's comprehensiveness and the necessity of verifying AI-generated code.